In all the previous sections, we spent a great deal of time looking at the nuts and bolts of Hyper-V and failover clustering. In this section, we're going to start looking at what is probably the biggest reason to cluster virtual machines, and that is virtual machine mobility. This first video is about live migration. The second video is about quick migration. The third video will examine automatic failover. The fourth video in this section is all about storage live migration. And the final video will cover shared nothing live migration. Live migration is the act of moving a virtual machine from one physical host to another without any perceived downtime on the part of the guest. The actual process is complicated, but not very difficult to describe. First, an empty instance of the virtual machine is created on the destination host. Next, the contents of memory are transferred. Then, all state information about the machine is transferred. Finally, the source copy of the virtual machine is stopped, the storage is reconnected to the destination, and it is started. If the start succeeds, the source VM is destroyed. If there are any problems, the copy is destroyed and the source continues running without interruption. The last part happens very quickly and is usually not detectable. However, as soon as the VM starts, one of the first things that happens is that its network adapter's MAC address must be registered on the physical switch, which means that ARP tables need to be rebuilt. This happens pretty quickly as well, but not quickly enough to prevent all interruption. The interruption can be detectable by way of drop packets. TCP will retransmit, so there shouldn't be a problem with that type of traffic. Other traffic types, like ICMP and UDP, will be lost. Because of this, some applications, like those involving voice over IP, don't support live migration. What doesn't happen during live migration is any motion of the underlying storage. It stays exactly where it is. Later in this section, we're going to look at storage and shared nothing live migrations in which the storage does move. But be aware that even though they have live migration in their names, they are not the same thing as live migration. One very important feature of live migration is that it has been very carefully designed to practically never result in a failed virtual machine. The entire process is reversible without interruption all the way up to the point where the virtual machine is turned on at the destination. If it won't start, then the source copy isn't stopped and everything continues as though the live migration was never initiated. You can use live migrations with virtual machines that are on cluster shared volumes, on SMB3 shares, or that are alone on a cluster disk. There are a couple of settings for live migrations. The first is restricting which networks it is allowed to use. When live migrations run, they will use as many resources as they can, which might drown out other traffic. So, you probably don't want them just running anywhere. Open Failover Cluster Manager and click on the Networks node. You can see all the networks here in the center pane. As you recall, we specifically set aside the 192.168.10.0 network for live migration. Let's rename that network here for easier identification. Now, right-click on the Networks node and click Live Migration Settings. All the networks that are checked are allowed to participate in live migration, unless the network itself has been specifically restricted from carrying cluster traffic. You can use the up and down buttons to change the sort order that you want these to be used. You probably want to pick at least 2 networks, just in case. There are no native PowerShell commandlets to modify this. You can use the registry if you like, although this requires some advanced scripting techniques that won't be shown here. The relevant keys are an HKey local machine, cluster, resource type, virtual machine, parameters. Next, open Hyper-V Manager and open Hyper-V Settings on a node. Go to Live Migration. Here, you can set how many live migrations can occur at once. A higher number means that more guests are moved at a time, but the more you have going at once, the slower each individual guest moves. Any beyond this number will be queued. The network selections here are ignored for clustered hosts. Click Advanced Features. The authentication protocol doesn't apply to live migration. We'll look at these when we talk about shared nothing live migration later. What we're interested in here are the performance options. The first option, TCP/IP, is how live migration worked prior to 2012 R2. When you start a live migration, a single TCP/IP stream would be open to the destination system, and all guests will travel through that. That meant that only one network path could be used at a time. The second option is for compression. This still only uses a single TCP/IP connection, but it compresses the contents of guest memory prior to transmission. If you've got spare CPU power, but your network connections are on the slow side, this might be the best option. The third option is for SMB. This is most useful when you have multiple physical pathways, as it can use SMB multi-channel. Or, if you have higher-end hardware, it can use RDMA. Make sure that all nodes have the same setting. That's everything for configuring live migration. To perform one, we'll go back to Failover Cluster Manager and access the roles node. Right-click on a running virtual machine and select Move, Live Migration. You can either let the cluster figure out what to do, or you can pick which node you want to move to. You can also use Control and click to queue up multiple machines at once. To do the same in PowerShell, you can use Move Cluster Virtual Machine Role. Specify the virtual machine with the name parameter. You can use Move VM. If the VM is turned on, it will automatically use live migration. You must specify a destination host with this parameter, though. This concludes our video on live migration. In our next video, we'll move on to quick migrations.